Hello and welcome to the video demonstration for the MLBreakout capstone project. The purpose of this project was to build a replica of Atari's Breakout and train a neural net with reinforcement learning algorithms from Unity ML agents to play the game. So that was the exact project description. What that actually means is we wanted to recreate Atari's Breakout game, which there's a screenshot showed over on the right-hand side. This game was originally made in the 1970s as one of the first computer games, and the gameplay was pretty straightforward. You want to control a paddle to bounce a ball into bricks, and when you bounce this ball into the bricks, it destroys the bricks. Unity is a game engine popular for developing mobile and online games. The idea was to recreate Breakout in this Unity game engine. Then after we have recreated the original Breakout game, we wanted to add in this machine learning component to control the paddle in the game. So we wanted to use reinforcement learning to train an AI to control the paddle. Reinforcement learning works by defining actions that an agent, where the agent is the AI-controlled object in the game, in this case it's the paddle. So we define actions that an agent can take. The agent then has defined observations that it is making in the environment that it's playing in, and defined rewards for different things that are happening in that game environment. On the bottom right-hand corner, you can see how the rewards for our agent will be structured in this game. The agent will have small rewards for moving the ball and the ball hitting the paddle, basically keeping the ball in play. It'll have larger rewards for the ball actually breaking bricks and destroying the bricks, which is the objective of the game, and it'll have a penalty for the ball failing. So we want to encourage the agent to keep the ball in play, encourage it to destroy bricks, and then discourage it from letting the ball fall out of play. And these rewards will again come up into this cycle that's shown in this diagram here, where the agent will have some defined actions that it can take, which is moving the paddle to the left or to the right, and then the agent is making observations about how that affects the game environment and how that can lead it to scoring points, basically, to optimize its reward. What made this project interesting to our team is that we get to have some exposure to machine learning, and more specifically reinforcement learning, by doing this game design. Reinforcement learning is being used heavily in a lot of applications, like self-driving cars and also general robotics control strategies. Here's a video of Cassie, which is a bipedal robot developed by a team at Oregon State, and it uses reinforcement learning to train its robot how to do behaviors such as running a 100-meter dash. Let's go look at our game now. The game is hosted online on GitHub. We built an online version of the game using the Unity WebGL tool. The user has a couple options here. They can play normal Breakout, which would just be playing the recreation of the Atari Breakout game that our team built in Unity, or they can play that same recreation of the original Breakout game, except also play it against a machine learning controlled CPU. Let's jump into playing against the CPU. Here, there's some options for choosing to play against different AIs that have been trained for different periods of time. Keep that in mind. We'll circle back to that training aspect in a little bit. We'll start by playing against the 30-minute trained AI, and on the left-hand side, you'll see me playing Breakout, and on the right-hand side, you will see the AI playing Breakout. Now you could already see that it has missed the ball once and it just missed it again. This 30-minute trained AI is able to do some of the basic tracking of the ball, but isn't very good at playing the game itself. Now let's go and restart a game against the machine learning CPU, except this time let's play against the 240-minute trained AI. And in this game, you can see that the AI does a lot better job of tracking the ball closely. And we're going to skip ahead here in a second to the end of the game, just making note of the number of lives that the AI has remaining. That's on the right-hand side of the screen up at the top. Here we are at the end of the game. You can see the AI hasn't lost a life yet. and we're about equal in the number of bricks that we have remaining, with myself playing on the left-hand side here. So yeah, you can see with this 240-minute trained AI compared to the 30-minute trained AI, this AI really does not lose the game of Breakout anymore. Now I want to expand on what I mean by a 30-minute trained AI versus a 240-minute trained AI. To make our machine learning controlled paddle, we use the Unity ML Agents package. That package consists of a Python package, which is running the machine learning algorithms on the back end, and also a Unity package, which is working within Unity to feed information about the environment to the Python package, which is doing the actual machine learning training. So here you can see I just started up the Python backend, and now I am starting up a training environment within Unity. So the game is playing at a rapid speed because the computer is playing and training itself. It's exploring different actions and seeing how those actions are affected by the conditions that are in the environment and how that can lead to different rewards in this game. Jumping back over to our slideshow, just to reiterate, we've just gone over our game and highlighted how we're able to play against a machine learning player and showed the interaction between Unity and the Unity ML Agents package. Now to jump over to some of our individual contributions. Can't go over this entire slide due to time constraints, but just to highlight some of the key things. This is for Aaron. Aaron worked on the initial game environment, working on the physics between the paddles and the walls, working on the ML training environment, and the code specific to the agent's observations and decisions and rewards, and some of the other scoring system features. Some of the challenges that Aaron faced included working with the physics of the ball and getting the magnitude of the vectors to remain consistent as it bounced off the different objects. Also working through some issues with the ML agents installations and setup, and then also really working on the observations, feeding quality observations to the ML agent to make the training effective. Since the last progress report, Aaron worked on training the ML agents for these specific times so that in the game you could play against an AI that has been trained for different periods of time and implementing that code to be loading a different brain.
Hi, I'm John Hammering, and what I did for this project overall was I worked on the menus, the scene management system, the win-loss condition setup, the life trackers, the WebGL build, and the original ML versus player level, so not the current one where you can select different ML agents depending on their length of training, but the one that was used as a basis to make that level, and that was made by my teammates. So I also worked on the project archives and the project plan. This was all done using a combination of Unity, C#, and then GitHub for collaboration. Some challenges I had were I had some technical issues with ML agents, as I couldn't get it quite to install correctly on my machine, but I worked through this with some help from my teammates, and then making the WebGL builds were another challenge, as I realized what looks correct on my machine might not look correct on, for example, a Mac user. The tasks done since the last progress report were I worked on and debugged the original ML versus player level, and finished how that scene now has to transition. This week, or the past 2 weeks, I also worked on the report and slides, and then made the WebGL build for the final project archive.
This is Vince. I worked on some of the game mechanics, such as the death detection and respawn system, the wind detection system when all bricks are destroyed, and generally just kind of testing the gameplay experience. Also worked on the project reports. Some of the challenges that I faced was really learning the new tools. No one on our team previously had experience with Unity or ML agents. We definitely learned a lot along the way with this project. Some of the tasks that I've done since the last report have been working on the game testing, creating the poster, working on this video, and also working on the final report. In conclusion, the game is functional. We met all the requirements that we needed to for this game of having the breakout game recreated and then having the ability for a player to play against a machine learning agent that has been trained to various times. Going forward, there will be no further development on this project, but all the team members will be taking the skills that we learned forwards. And yeah, we had a great time working on the ML Breakout project. Thank you.